Okay, what we're going to be going over today, or in this little short video, is your Proto Board. That's this little device right here. This is where you're going to be creating, to start off with, your little DC circuits. I'm going to show you that by checking resistance or checking continuity between the holes up here. And we have a hole of rows. I don't know if you can see them. We have a roll of hose that go down the entire length of the board. They go across here, and then we have another row that go across here. Those are horizontal as I'm holding it. Vertically, we have a set of 5 holes in this row. We have another 5 set in this row, and in a separate section we have another 5 set over here, and we have 2 rows of horizontal holes at the bottom that are primarily the same thing as what they are at the top. We start off by, and I'm going to show you with continuity, showing something that you have already used inside of lab here. You checked resistors and you measured the resistance of each one of them. What we're going to do first off is check our meter. I have it set on resistance. I have the leads in the correct holes in the correct jacks. And I check the functionality by shorting the 2 leads together and reading the display on the meter, and it shows me pretty much that there is 0 continuity between my leads, and that's checking to see if the meter works. What you don't want to do ever is grab a piece of test equipment and not know if it's working or not. You always want to check it. Now what I'm going to show you is that the row of holes that go across the Proto Board itself are common to each other. So I'm going to just simply stick a resistor in one of these holes, and I'm just going to pick another hole somewhere in that same line, and we're going to check continuity. Let me get my hand out of the way. And if you could see on the meter itself, we show 0.2 ohms, which is pretty much no resistance. So we have just proved that at least those 2 holes are the same electrically. Let's just go down another one just because we can, and go check it again. And if we look at our meter, if you can see it, we're showing 0.3, 0.2 ohms. So that has verified that this row of holes are common to each other. Electrically, it's the same thing. Now we'll go and check this other row just to make sure, because that's what we do. We always verify before we take anything for granted. And we will check the continuity between these 2 leads on the resistor, and as we can see by the meter itself, we're showing pretty much 0.2 ohms again. So that tells us that this row of holes is electrically the same thing, and this row of holes is also the same thing, and that goes along with the bottom rows over here. Now we're going to look at these holes, these sections of 5 holes. This row is common to itself, but it is isolated to the row next to it on either side, and we're going to prove that. So what we do is we take one of our resistor leads, and the reason I'm using those leads is because they go inside the hole and make a real good connection, so we can verify that these are true. What I'm telling you is true. And if we check the resistance between those 2 leads, we come up with 0.2 ohms, 0.1 ohms. So that's telling me that all 5 of these holes are electrically the same. Now if I just move over 1, I'm going to shove it in there. Now I have my resistor leads in 2 different rows, and watch the meter. We're going to see if those 2 are isolated like I told you, and we're still showing an OL on our meter. They're not connected. Electrically, they are isolated. This row is isolated from this row, which is isolated from this row. So you have a lot of rows here to select when you're building your DC circuits. And the same holds true for this set of 5 holes down at the bottom. Each row itself is electrically the same, but they're isolated from the row next to it and the other row next to it. So you have options here. You have rows here you can utilize. You can have a common header up here on top and bottom, both. that you can utilize when you build your DC circuits. You'll find your own method of what makes sense to you when you're building them. I have seen people build their circuits to where they're exactly as they're drawn from their schematics. I have seen people make what looked to be a total mess, but in their mind's eye, they can see how the circuit is built and it makes sense to them. Any way you can do it, and you're going to find your own way, you can do that, as long as when we ask you for a certain reading on a certain component, you don't have to guess which one it is. You built it, so you should know the difference between all the resistors on the board and what they reference to on the schematics.